my dear students. Today we discuss about another part of light, that is dual nature of matter and radiation. Dual nature of matter and radiation. Okay. So before we discuss about this chapter, we have to know. We know actually wave. What is wave? Wave is a disturbance of the particles of a medium. Wave is a disturbance of the particles of a medium. Okay, so in previous lectures we discussed about light. So when we discuss about light, this part is known as actually optics. Okay, so light can be obtained in two nature. That means it behave as a particle and it behave as a wave. Okay, so at first Newton, okay, Sir Isaac Newton explained that light is a particle. At first, Newton explained that light is a particle. Okay, so that particle is known as corpuscle. So when the light behave as a particle, then it can represent as a ray. So that particle is known as corpuscle. Okay. So on the basis of this, Newton discussed about light through a theory which is known as Newton's corpuscular theory. After that, 18th century, Huygens, a Dutch scientist, Huygens, explained that the light is a wave. Light is a wave, for which it shows interference, diffraction and polarization type of phenomena. So when light shows particle nature, then it satisfies some scattering phenomena. When light shows particle nature, and it satisfies some scattering phenomena. But when light shows wave nature, then it satisfies interference, diffraction, polarization and such type of phenomena. Okay. So next, so wave nature. So this wave nature of the light was firmly established by Maxwell's equation of electromagnetic wave. After Huygens, wave nature of light was established by the Maxwell's equations of electromagnetic wave. Okay. So after that, Hertz experiment of the production and detection of wave, that it explained that light is a electromagnetic wave. Okay. So in 1895, Röntgen, okay, our scientist Röntgen discovered X-ray. When cathode particles, that means when cathode rays are incident on the anode plate, that means electrons are incident on the anode plate, which is placed at an angle 45 degree with the direction of incident beam, then some scattering, that means some rays are scattered from the anode plate. So that was discovered by anode. That was discovered by Röntgen. Okay, so he considered these unknown rays as named as X. So after his death, these rays are known as X-rays to respect him. Okay, so to respect him, these rays are also known as Röntgen ray, or it is an unknown rays. According to Röntgen, it was unknown at that period, so it is known as X-rays. Okay, then after that, in 1897, J.J. Thornton discovered electron. Okay, so the experimental proof of the existence of negatively charged particle electron was established by the conduction of electricity through gaseous medium. Okay, so gaseous medium at a very low temperature. That means existence of negatively charged particle electrons was established by the conduction of electricity through a gaseous medium at low pressure. Okay, so in an evacuated glass tube, that means which is known as cathode tube. In cathode tube, already we know, in cathode tube it consists of a cathode and anode. It consists of cathode and anode. One end cathode, which is known as emitter, and another one is known as opposite end is known as anode, which is known as collector. Okay, so this tube is evacuated glass tube, and it can be vacuumed by using a vacuum pump. Okay, it's a vacuum pump. It can be vacuumed. Okay, so when and in between the cathode and anode, in between like this is this cathode tube like this. This is a cathode tube. This is cathode and this is anode. Cathode and this is anode. Okay. Here potential difference is supply. Okay. So there is a vacuum pump. There is a vacuum pump. Okay, so this is gas discharge tube. Okay, that means it consists of gas discharge tube. That means it consists of gas. Okay, so here, if electric field is supplied in between this cathode and anode, then the electrons, that means negatively charged particles, are emitted by. That means negatively charged particles are emitted from cathode to anode. So how it is happen? This is a cathode tube. It is a evacuated glass tube. It is a evacuated glass tube. Here jitu vacuum pump ase, a pump to threading, its pressure can be minimized. That means its pressure can be maintained. If here pressure to ki kopari maintain koribo pare. Jetia cathode aru anode majot high voltage supply di pelai cathode pra anode supply di pelai ইয়াৰ যেটো প্ৰেছাৰ যদি কমাই গৈ থকা হয় তেতিয়া দেন cathode পৰা anode কিছুমান ৰেজ এমিট হ'ব আৰু এটো যেটো গ্যাস টিউব মানে কিছুমান ৰেজ এমিট হ'ব আৰু সেই যিখিনি ৰেজ এমিট হ'ল that rays affect on this screen এই স্ক্ৰিনখনৰ নাম হৈছে fluorescent স্ক্ৰিনখনৰ নাম কি fluorescent screen ঠিক আছে এই fluorescent স্ক্ৰিনত যেটা ই পৰিবগে পৰাৰ লগে লগে ইয়াত কি হ'ব ইয়াত ব্ৰাইট ফিচাৰ হ'ব মানে আলটিমেটলি এই স্ক্ৰিনখন কি হ'ব ফ্লাছ হৈ যাব না ব্ৰাইট হৈ যাব তেতিয়া সেই যেটো ৰে যাব এই যেটো ৰে cathode পৰা anode গৈছে so that ray is known as cathode rays okay so this cathode ray how it is possible okay so the experimentally proof of the existence of negatively charged particle electrons okay negatively charged particle electrons is produced by the conduction of electricity through gaseous medium at low pressure okay so when electric current is passing through in gases at low pressure what will be the pressure is 0.001 millimeter of Hg pressure is that means 10 to the power minus 3 millimeter 10 to the power minus 3 millimeter of Hg column iman 10 to the minus 3 millimeter or parar স্তম্ভৰ উচ্চতাৰ চাপৰ সৈতে প্ৰেছাৰ সৈতে সমান প্ৰেছাৰত যদি হাই ভোল্টেজ সাপ্লাই দিও here this is negative and this is positive high voltage যেতিয়া সাপ্লাই দিও this is HTB মানে high tension battery high voltage যেতিয়া তুমি সাপ্লাই দিবা high voltage সাপ্লাই দিয়া লগে লগে এই ক্যাথোডৰ পৰা এনডলে কি গুচি গল কিছুমান ৰেজ ওলাই গুচি গল so that rays are known as cathode rays okay so what is cathode ray when electric current is passing through a gaseous medium at low pressure, that means 10 to the power minus 3 millimeter of mercury column at mercury column due to presence of a high tension battery in between cathode and anode, then a ray is emitted from cathode to anode. That ray is known as cathode rays. Okay, so this cathode ray is a negatively charged particle. It is moving in straight line. Cathode rays are moving in straight line. Cathode ray khini kenake move kore? They are moving in straight line. Hiহঁতি সদায় straight line on move kore. First one. Second one, cathode rays consist of negatively charged particle. That means electron. Cathode ray ki thake boli kole? The cathode ray consists of negatively charged particle, electron. ইয়াৰ পৰা ইয়ালে এনেকে ওলাই গুচি গ'ল আৰু সেইখিনি কি বুলি কলে? Negatively charged particle, electron আছে বুলি কলে. ঠিক আছে? Next, they have a penetrating power. Penetrate, সিহঁতি সোমাই যাব পাৰে. They have a penetrating power. And penetrate কি হ'ব? It can easily penetrate thin aluminum or gold foil. This thin aluminum foil, gold foil, easily ইহঁতি কি কৰিব পাৰে? পাৰ হৈ যাব। It can penetrate. So cathode ray consists of negatively charged particle. So it is affected by electric and magnetic field. Electric আৰু magnetic field এই cathode ray কি কৰিব পাৰে? Affect কৰিব পাৰে। বুজি পাইছা? This is negatively charged, so it is affected by electric and magnetic field. Okay, so these are the properties of cathode rays. It can moving with speed of light, or it can moving with speed 1/10 of the speed of light in vacuum. That means 3 into 10 to the power 7 meter per second. Cathode rays are emitted, that is moving with speed 3 into 10 to the power 7 meter per second. That means it consists of electron. Okay, so speed of electron is 3 into 10 to the power 7 meter per second. That means it is 1/10 of the speed of electron. Okay, so after this conclusion, that means after the conclusion of J.J. Thomson experiment, that means it travels in straight path, it has a penetrating power, okay, it can be affected by electric and magnetic field, okay, and it has negatively charged particle. So from this at first Crook, from this observation, William Crook verified that. That means William Crook concluded that cathode rays consist of negatively charged particle, electron. সেই conclusion পিছতে William Crook কি কলে যে cathode ray কি থাকে বুলি কলে is a consist of negatively charged particle. যদি আগতে কৈছিলে যে সেই particle to this cathode rays are affected by electric and magnetic field. That means the cathode rays, if you apply an electric field, then the cathode rays is moving towards the positive plate. Suppose this plate is positive, suppose this is negative. If you apply an electric field in between them, then if cathode rays are moving from this to this, then it is moving like this. It is moving like this. Okay, so due to presence of electric field is applied like this in downward direction, okay, and a magnetic field is applied like this. Okay, if we apply an electric field in upward direction, okay, that means this is y-axis, and if we apply a magnetic field in this direction like this, okay, suppose this is inward direction. If electric field is applying upward direction and electric field, this is positive plate and this is negative plate, that means downward direction. Electric field is downward direction and magnetic field is inward direction. Then the due to presence of this negatively charged, the cathode rays is moving upward direction due to presence of electric field. If at that position a magnetic field is applied, then it is moving in this direction like this due to presence of magnetic field. Eto magnetic field of karone ki kon phale jabo? Due to presence of Fm. Magnetic field of force karone ki hobo tolole and due to presence of electric field, it moving in upward direction. Okay. If both are equal, then it is moving, then it is undeviated, then it is moving in this direction. If Fe equal to Fm, that means force acting by electric field and force acting by magnetic field becomes equal, then the particle is moving in straight path, that is undeflected. Okay, so from this observation, William Crook conclude that the cathode rays consist of negatively charged particle. Okay, so after that, in 1900, Hertz experiment on the electromagnetic wave. William Hertz experiment. Leonard actually experiment on the basis of electromagnetic wave. Then in 1901, that means Max Planck study about the radiation, that means on the basis of electromagnetic wave. In 1901, Max Planck explained that light radiate, that means electromagnetic wave is a electromagnetic wave, it radiate in this continuous bundle of packets, which is explained in 1901. And in 1927, Louis de Broglie, and before in 1913, Millikan's. In 1913, Millikan experiment, his famous experiment, which is known as Millikan's oil drop experiment. In 1913, first 1901, Max Planck Max Planck 1901, Max Planck concluded that light radiate in this continuous bundle of packets and is known as quanta. So each quanta having energy, that is E equal to, each quanta have, according to Max Planck, each quanta having energy is E equal to h nu, where h is Planck's constant, according to Max Planck. Okay. Right, so equal to h nu according to Max Planck, and it is known as Planck constant. This is 6.625 into 10 to the power minus 34 joule second. Planck's constant h is equal to 6.625 into 10 to the power minus 34 joule second. According to Max Planck, light radiate in this continuous bundle of packets. Each bundle of packets, each packet is known as quanta. Okay? And each light particle is known as photon. The particle to naam ki boli koa asile? Photon, not proton. Particle, name of the particle is photon, and each photon has an energy, that is h nu. Each photon has an energy h nu. That means light particle. According to Max Planck, the light particle is known as photon. That photon particle has a definite energy. This is equal to h nu, which is discussed in 1901. Okay. Next, after this, in 1913, Millikan oil drop experiment. In 1913, okay, visualization. In 1913, Millikan's oil drop experiment. He determined the charge of electron. Calculate the charge of electron, and by which in this experiment he determined the value of specific charge of electron, that is E by m, mass of charge, electron of charge of electron, and mass of charge. So in Millikan-Oildov experiment, he determined the value of E by m also. That means which is called as specific charge. Already J.J. Thomson determined the value of specific charge of electron, that is 1.76 into 10 to the power 11 coulomb per kg E by m. According to J.J. Thomson method, this specific charge, which is known as E by m, is specific charge. What is specific charge? Is the ratio of magnitude of charge and mass of electron. Okay, so this is equal to 1.76 into 10 to the power 11 coulomb per kg. 1.76 into 10 to the power 11 coulomb per kg of electron. Okay, so Millikan in 1913, his famous experiment known as oil drop experiment determined the charge of electron in his experiment in 1913. Okay, then he concluded charge of a body is quantized. So what do you mean by quantized? Quantized means it is an integral multiple. Quantized means it is an integral multiple of elementary charge of electron. That means if you consider a charge of a body, that means Q is equal to plus minus Ne. That means Q equal to N. This N equal to 1, 2, 3 like this. And E equal to charge of electron 1.6 into 10 to the power 19 coulomb. E equal to charge of electron 1.6 into 10 to the power 19 coulomb. According to Millikan-Oildov experiment, the charge of a body is quantized. That means it is integral multiple of elementary charge of electron. That is Q equal to plus minus Ne, where N is whole number. That is 1, 2, 3. Integral multiple. Okay? So N equal to 1, 2, 3. That is integral number. Okay? So next, after this, in 1927, Louis de Broglie explained that the particle associated with matter represents a wave. That means the wave associated with the particle of matter, the wave associated with the particles of matter is known as matter wave in 1927. Okay, so then in 1927, from Planck's theory and from his matter wave, he explained that light shows dual nature. That means we get dual nature of matter. That means according to Planck's radiation method, that is Planck's quantum theory, and his matter wave, Louis de Broglie in 1927 explained the dual nature of matter and radiation. Okay, so this experiment, that means Louis de Broglie's experiment, is verified. After that, Davison-Germer experiment, that means Davison and Germer in electron gun experiment verify Davison and Germer. Okay. Further, Davison and Germer. Davison and Germer further experimentally verified the de Broglie hypothesis, that is 1927. This is de Broglie hypothesis was established in 1927, and further Davison and Zarmer experimentally verified this de Broglie hypothesis. Okay, so now we discuss about how electron can be emitted from a surface. Okay, so next topic is emission of electron. Emission of electron. That means electron emission. So what is electron emission? Electron emission means the process of emission of electron. The process of emission of electron from a metallic surface is known as electron emission. Emission of electron from a metallic surface is known as emission of electron. That means electron emission. Okay. So electron emission means, that means we know, if you consider an atom, we know metals, in metals the electrons are loosely bound with the nucleus. In case of metal, the electrons are loosely bound with the nucleus. So in that case we get some bound electron and some valence electron. Okay, so bound electron which are obtained in, that means which are obtained in near orbit, that means sp, like this is the first orbit, second orbit. Okay, so the electrons which are bound with the nucleus, the electrons which are tightly bound with the nucleus is known as bound electron. That means they are tightly bound with an electrostatic force of attraction with nucleus. Okay, and if the number of orbit is increased, then the attractive force, that means electrostatic force in between them, is decreased. Okay, so the electrons which are obtained in the outermost shell is known as valence electron. Okay, so these valence electrons are loosely bound with the nucleus. It is also known as free electron. This is valence electron. It has a tendency to become free from the outermost shell. Okay, so that electrons are known as free electrons. Okay, so these free electrons takes responsibility for the conduction of current. These free electrons takes responsibility for the conduction of current. Okay, so if you apply an electric field, these free electrons are released from the outermost shell. If you apply an electric field, these free electrons are released from the outermost shell. Then, when, suppose this is an atom, this nucleus, this is shell, outermost shell. So these are bound electrons. Suppose this is bound electron. And this is free electron, outermost shell. This is positive charge, this is nucleus. Okay, suppose Zd, this is nucleus, and this is bound electron, and this is free electron, and this they are obtaining outermost shell. Okay, so when an external energy is supplied to it, then these free electrons, that means this free electron has a tendency. This free electron has a tendency to move this orbit. Okay, so these free electrons are responsible for the conduction of current. So when these free electrons has a tendency to release from it, then a oppositely charged particle attract to back up its position. That means an oppositely charged particle attract to it, attract the free electron to get its initial position. Initial position to bring it initial position, a oppositely charged particle, that is positive charged particle, attract this electron which is released from it. So that positively charged particle is known as surface barrier of electron. That is known as surface barrier of electron. Okay, so this process of emission of electron from the metallic surface, this process of emission of electron from the metallic surface is known as electron emission. Process of emission of electron from a metallic surface is known as electron emission method. Okay, so the amount of energy required, a small amount of energy required to release the electron from this metallic surface. That means to eject the electron from metallic surface, a minimum amount of energy is required. So that energy is known as work function. Work function. Work function. So what is a work function? The minimum amount of energy required to eject the electron from the metallic surface is known as work function. It is always expressed in electron volt. Always expressed in electron volt. EV. Electron volt. So what is electron volt? Electron volt means 1 electron into 1 volt is 1.6 into 10 to the power minus 19 coulomb into 1 volt. Okay, so it will be 1.6 into 10 to the power minus 19 coulomb into volt joule. 1 electron. So what is 1 electron volt? 1 electron volt is the energy attained by an electron when it accelerates through 1 volt potential difference. 1 volt potential difference or মাজেৰে ইলেক্ট্ৰন এটা এচিলাইট কৰিব কাৰণে যেটো এনাৰ্জি দৰকাৰ হয় সেইটো এনাৰ্জি হৈছে 1 ইলেক্ট্ৰন বুজি পাইছা the amount of energy required to eject the electron from a metallic surface is known as 1 electron volt. Oh sorry, amount of energy required to attain 1 electron volt is the energy required to accelerate through 1 volt of potential difference. Energy required by an electron to accelerate through 1 volt potential difference is 1 electron volt. Okay? So work function means the minimum amount of energy required to eject the electron from metallic surface is known as work function. Okay? So this work function always expressed in electron volt, but it is represented by work function can be represented by unit of work function is electron volt, but it is represented by phi or W naught. Phi or W naught. Okay. The minimum work function of the element is cesium. Minimum work function 2.14 electron volt. Cesium, minimum work function. And maximum work function of the element is platinum, that is 5.65, I think. 5.65 electron volt. Minimum work function, see this book? You see the book? Yes, cesium 2.14 electron volt, platinum 5.65 electron volt. This is maximum and this is minimum. Maximum and minimum work function. We can over. So what is the minimum value of work function? That is cesium. Name of the element is cesium and 2.14 electron volt, and maximum work function platinum is 5.65 electron volt. Okay. So next we discussed about electron emission. Okay, so what is electron emission? So types of electron emission. Okay. So next class we discuss about types of electron emission. Okay. Thank you.